In fact, soil health indicators have already been proposed or are subject to current researches in order to characterize the fragility of soils and also their reactions for threats. And most of the results have been obtained until now on agricultural soils. There is nearly no risk when we do interpolation, but risks are great when we do extrapolation. And so agricultural soils are very different from forest soils, from urban soils, and also from industrial soils. Beyond that, in fact, there is a problem of the interpretations of the value taken by these indicators. For example, on forest soils and on agricultural soils, the same value cannot be interpreted in the same manner. For example, soil nutrients in the content of nutrients in forest soils are generally very low. It's normal, while soil content in nutrients in agricultural soils are high, and it's no sense to compare this value without having two different referentials for these two types of soils. Satellite-based observations, Earth observations, have already been used in many studies on the interface soil plant atmosphere. In fact, data may characterize soil moisture, soil structures, biomass over the soil, and coupled with a model combining the soil, vegetable and plants and atmosphere fate, we can estimate biomass productions and other things, flux of water, flux of carbon dioxide, etc. Dealing with soil health indicators, in fact, satellite-based Earth observation are particularly adapted to the last three indicators proposed by the Mission Board Soil Health and Food, that are soil cover, forestry on soils, and also land heterogeneities. And maybe satellite-based Earth observation may also characterize soil organic content in organic carbon content, but maybe only on bar soils or crop soils, but not on forest soils. And it may be very useful for us to access this information with high definition and with a high frequency without measurements.